Hi students, today we're going to do section 3. Mechanical advantage. Mechanical advantage is the number of times the effort force is multiplied by the machine. So it's how much the machine is improving whatever force you're putting in. So the bigger the mechanical advantage, the better this machine is because it's less force you have to put into it. There must be an advantage to using machine, otherwise there's no point of using it, and this is the point. The mechanical advantage tells you how good the machine is. Ideal mechanical advantage, which is IMA. The ideal mechanical advantage is the mechanical advantage in the absence of friction. And the equation is IMA equals dE over dR. That equation will be given to you on the test. The actual mechanical advantage is the mechanical advantage without friction included. And that is AMA equals FR over FE. Because actual mechanical advantage includes friction, the actual mechanical advantage will always be less than the ideal mechanical advantage. Efficiency is the percent of work input that becomes work output. Due to friction, no machine is 100% efficient. So there are two equations for efficiency. Either works fine. For your worksheet, you'll have to use both. Work output over work input times 100. Remember, work output is always less than the work input because of friction. And efficiency is equal to AMA over IMA times 100%. And AMA is always less than IMA because of friction. Okay, so you will see a problem like this on your worksheet as well as your test. So here is the example. You've got somebody pushing up a box up a ramp. The person is pushing with 30 newtons. The box is 40 newtons. The ramp is 6 meters long and it's 2 meters in height. And you will see this on your test, so it's important to know how to do it. It'll be lots of points on your test. So you first want to figure out your FE, your DE, your FR, and your DR. So your FE is what the person is doing, and the person is pushing with 30 newtons. Remember, force is always measured in newtons. Your DE is the distance that person is moving, and that person is moving 6 meters. Remember, distance is always in meters, force is in newtons. Your FR is the force that the machine is doing, and the machine is lifting 40 newton box, so it's 40 newtons. And your DR is the height, or whatever the distance that the machine is moving it, and in this case it's the height, which is 2 meters. First, you'll always want to write down the equations. So work input is equal to FE times DE, which will be 30 newtons times 6 meters, which was gotten from up top. 30 times 6 is 180 joules. Remember, work is measured in joules. Work output is your FR times your DR. FR is your 40 newtons times your 2 meters, because that was your DR. 40 times 2 is 80, and that's also measured in joules. IMA is DE over DR, which is 6 meters over 2 meters. And in the IMA, the meters cancel out, so IMA does not have a unit. So 6 divided by 2 is 3. If you write a unit, you will be docked. AMA is your FR divided by your FE, which is 40 newtons divided by 30 newtons, and your newtons cancel out, and this equals 1.33. Now, there'll be two more things that you have to solve for using the information you just used. So you will want to solve for efficiency both ways. The first one is work input divided by work output times 100%. If you look back at the previous screen, your work input was 180 joules, and your work output is 80 joules. You might have realized I screwed up on the equation. It should be work output over work input. So you're going to take your 80 joules and divide by 180 joules, and you'll times it by 100%. So 80 divided by 180 is 0.44, and then you times it by 100, so times it by 100, the joules cancel out, and you'll get 44.4%. Efficiency, another efficiency is your AMA over your IMA times 100%. Your AMA over here on the previous screen was 1.33, and your IMA was 3. So this is equal to 1.33 divided by 3 times 100%. So if you take 1.33 divided by 3 and times it by 100%, I got 44.3%. They should technically be the exact same. They're not because we rounded the 1.33.